Okay, in the previous class, we have studied that reflection of light through plane mirrors. So, what are the properties of characteristics of the image which is formed by plane mirror? All we have studied in the previous class. Now, this class is very important for the 10th examination board, and also it is most important for the MSET examination also. Reflection of light through curved surface. Reflection of light through curved surface. Curved surface. It's a great topic. I'm going to discuss here curved surface here. Okay. Yeah. So what is the curved surface? Before going to explain the curved surface, we know that here one of the sphere. Sphere is a hollow sphere. This is my hollow sphere. This is the hollow sphere here. So I cut into two parts. I cut into exactly the middle here. For example, I cut in two parts here. Let us let be. So this image like that here. This part is like that here. This is this part like that. So this part. So inner surface, sir. This figure has two surfaces. One is the inner surface. Other is the outer surface. Inner surface is called as a hollow surface. Hollow surface. Inner surface is called as a hollow surface. Next, outer surface is called as a bulged surface. Bulged surface. The surface is called bulged surface. Okay, it is a part of the sphere. It is a part of the sphere, and if you divide this, if you observe the part of the sphere, so it is like that. So inner surface, for example, in our home we have a spoon like that here. This spoon. It is like a spoon here. So inner surface is called as a hollow surface, and outer surface is called as a bulged surface. Bulged means they are liking. So that is called as a bulged surface. Okay, right. Next here, so depends upon the that here reflection always takes place on the opaque surface. That's why one of the surface should be silver coated. So silver coat means it is a non-reflecting surface. Non-reflecting surface means it is not a reflecting surface. Other surface should be reflecting surface. So based on the reflecting surface, we can classify into the surface are two mirrors are two types of mirrors. One is a convex mirror. So right here, this is a first is a concave mirror. Concave mirror. The next mirror is called as a convex mirror. Convex mirror. Okay. Yeah. Concave mirror means here, if a bulged surface, this is a bulged surface is silver coated, or if a hollow surface is a reflecting surface, then the type of mirror is called as a concave mirror. So this is a my concave mirror. So this is a my concave mirror. So hollow surface should be reflecting surface. Hollow surface means inner surface. Inside the that mirror should be silver coated. Sorry, not silver coated. It's a reflecting surface. That is called as a concave mirror. Outside bulged surface should be silver coated. This is called as a concave mirror. Next, what about the convex here? That is a outer surface should be reflecting surface. Inner surface should be silver coated. This is called as a convex mirror. This is called as a concave mirror. So in the examination, board examination here, he may ask questions here. Define convex mirror. Define concave mirror. Simply we can say that if the reflecting surface is concave surface means hollow surface. If the reflecting surface is hollow surface, that mirror that type of mirror is the concave mirror. If the reflecting surface is convex surface, that type of mirror is called as a convex mirror. Yes. So these are the types of the mirrors. Now we are going to discuss the some terminology which is belongs to the these spherical mirrors. Please take the screenshot, all of you. Yeah, next here, terminology belongs to spherical mirrors. Spherical mirrors. So terminology belongs to spherical mirrors. Okay. So this is very very important for 10th examination board here. He may ask here 4 marks question, or otherwise it is 8 marks question. It may ask also 2 marks question also. Yeah. First one is here. So first terminology. For example, if you take concave mirror, this is my concave mirror. Concave mirror means here the concave mirror should be reflecting surface. Means hollow surface should be reflecting surface. That type of mirror is called as a concave mirror. This is a concave. This is called as a concave mirror, and this is called as a convex mirror. So bulged surface should be reflecting surface. This is a convex surface. Convex surface. Convex mirror. Okay, yeah. First terminology, that is the first is here pole. What is the pole? Pole means here it is a midpoint or center point of the mirror. So this is my mirror, concave mirror. So this mirror has a center point. This center point is called as the pole. This is called as the pole. Pole of concave mirror. This is my pole of convex mirror. Pole of convex mirror. Okay. Yes. What is the pole here? It is a midpoint. It is a midpoint of a center point. Midpoint of spherical mirror. Midpoint of a spherical mirror. So spherical mirrors. It may concave mirror, convex mirror. So midpoint of spherical mirror, center point of the spherical mirror. That is called as a pole. Next terminology. Next is here. Next I can write center of curvature. Center of curvature. Center of curvature. What is center of curvature? So this is a part of the sphere. So it is actually spherical mirror is a part of the sphere. If you complete that this mirror, we get one sphere, one circle here. So the sphere has center. That is center here. This is called as a center. This is imaginary center. Actually it is a part of the sphere. Central curvature is a part of the sphere of which that central curve is a part of the sphere. Mirror is a part of the sphere. So this is the imaginary center of imaginary center. Okay, or it is a part of the sphere. It is part of the sphere of which mirror is a part. So it is a center of sphere, center of sphere of which mirror is a part. Mirror is a part of sphere, part of sphere. So every curved surface it has center, imaginary center here. That center is called as a. For example, if we take this is small convex mirror, we have small center. Please meet yourself, all of you. Subhasri. Yeah, next here, if we take the big curved surface, the other center is exactly center. Okay, this is the center of curvature, which is represented by letter C. Is my letter. Okay, next one is here radius of curvature. So radius of curvature. What is the radius of curvature? It is the radius of the sphere of which mirror is a part. So here, for example, if you take this is my concave mirror. This is my center point here. So this is the distance between the center of curvature and circumference of the any point. If you draw the line from center to circumference of the any point on the mirror, that is called as the radius of the sphere of which mirror is the part here. Mirror is the part. So for example, this is also radius of curvature. This is also radius of curvature. For example, if you take for instance sphere or otherwise circle here. So radius means here it is a distance between the center of the circle and any point on the circumference. That is called as a radius. This is the radius r. This is the radius r. Same thing also. Okay. It is the radius of the sphere. It is the radius of sphere. It is radius of sphere. Radius of sphere of which mirror is a part. Mirror is a part of sphere. Part of sphere. Okay, this is the radius of curvature that is represented by capital R. Or simply we can say that here is the distance between the center of curvature and any point on the spherical mirror. That is the radius of curvature. That is the radius of curvature. Yes. Next point. Next is the principal axis. The principal axis. What is the principal axis? So if we take concave mirror, this is the center of curvature, and this is my pole. This is the pole of the concave mirror. The line, this is the line joining of center of curvature and pole. That is called as the principal axis. So, for example, if you draw the line which is passing through the center of curvature and pole, that line is called as the principal axis. Principal axis of that mirror. This is the principal axis. Principal axis. Okay. Yes. Principal axis means line joining of center of curvature and pole is called as a principal axis. So we need to note down here. This is very important here. Principal axis here. It is line joining of center of curvature and pole. That line is called as a principal axis. So this is it is same for the concave and convex mirror. That should be joining the center of curvature and pole of the mirror. This is the four terminology. Then go for the next terminology. Yeah. Yes, this is my concave mirror. This is my principal axis. This is my center of curvature. This is my pole. And this is my radius of curvature. Okay. Next here. Next, very important here. Next point here. Fifth one. Principal focus. Which is represented by capital F. Yeah. Principal focus. So we need to define the principal focus for the concave mirror and convex mirror. So we need to define this is one of the important question for the 10th class board examination. This is a 4 marks question. So define or draw the ray diagram of principal focus for a concave mirror and convex mirror. Concave mirror and convex mirror is very important here. We need to know that ray diagram also. So I want to take first the concave mirror. This is my concave mirror. This is my concave mirror means here hollow surface should be reflecting surface. That type of mirror is called as a concave mirror. Yeah, and for every time you draw a pole. You locate the pole and center of curvature. Depends upon the curvature. So C also changes. If it is small curvature, we are small. Distance between the center and P is very small. If it is big curvature is there, radius also more. So I can take here. This is my center of curvature. So if you join center of curvature and pole, that is called as the principal axis. If you join the center of curvature and the pole, that line is called as the principal axis. Yeah. Next one. Now I want to define the principal focus for concave mirror. For that, so I can take a parallel beam of rays. You know that already. Parallel beam means here the lines which are parallel to each other, and distance between the ray to ray is very small. Okay. For example, I can take 2 rays only. This is the first ray, and this is my second ray. This is my first ray, and this is my second incident ray, which are coming from the object here. Okay, these are the parallel rays. 3 rays I can take here, otherwise we can take 2 rays. This is my incident rays, which are fall on the concave mirror. Yeah, you know that according to the law of reflection. So first to draw the normal. Before that, I want to define normal here. This is fifth one. Again, this is sixth one. And taken fifth one is the normal. What is the normal? Normal means here, for example, this is my concave mirror. This is my center of curvature. This is the pole here. So what is the normal at this point? Normal means here, just for example, this is my incident ray. Okay. So what is the normal at this point means just join the point of incident where the light is incident at this point. Just join this point and center of curvature. That line is called as a normal. So this is my normal. For example, light is incident at this point. Just join this point of incidence and the central curvature. This is called as normal here. What is normal? It is a it is a it is the distance between the point of incidence and the central curvature. That is called as a normal. Okay, coming to this point here. So this is a ray which is incident on this point on the concave mirror. Yeah, just draw the normal. First of all, if you want to apply law of reflections here, definitely after light incident on the mirror, we need to draw the normal at this point. Normal means just join this point of incidence and central curvature. That is called as a normal. This is my normal. This is my normal. Okay, and you know that here. What is angle of incidence here? Angle made by the incident ray and normal. So this is the incident ray and this is my normal. This angle is called the angle of incidence. Angle of incidence. You know that here is the reflected ray. That must be normally is in between the reflected ray and the incident ray. Definitely the reflected ray must be in this direction. So this is the downward direction. This is my reflected ray. I want to indicate with different color here. This is my reflected ray. So I want to indicate direction away from the mirror. That ray is called as a reflected ray. This angle also called as angle of R. Okay, next here. So the second ray I will take here. This is my second incident ray which fall on at this point and draw the normal, which is normal means here join the point of incidence and the center of curvature. This is my normal and this angle is called the angle of phi. Where is the reflected ray which is above the normal? Exactly, this is my reflected ray. I want to indicate with different color here so that we can understand. This is the
Sir, sir,
what?
sir, your voice is not audible, sir.
Okay. Mute yourself. Right. So this is a this is called as a reflected ray for the second incident ray. This angle is called as the angle of R. Tell me now. Yeah, this is for first incident ray. This is my reflected ray. For second incident ray, this is the reflected ray. They are meeting at one point on the principal axis. That point is called as the principal focus. Principal focus. Okay. So what is the principal focus for the concave mirrors here? A beam of rays parallel to principal axis. After reflection, they pass through a point on the principal axis. That point is called the principal focus of that mirror. I write the definition here. A beam of parallel rays, fall on mirror, concave mirror. After reflection, they meet at one point. They meet at one point on principal axis. That point is called as is called as principal focus of concave mirror. This is the definition here. She may ask 4 marks question here. Okay, na? So draw the ray diagram of concave mirror and also define the definition of principal focus of concave mirror. Okay, simply here, what is a beam of parallel rays? So we can take parallel beam of rays here. After reflection, they meet one point here. That point is called the principal focus of concave mirror. So here, in this case here, concave mirror. In case of concave mirror, all reflected rays they are meeting at one point. Okay, all reflected rays are meeting at one point. That is a really meet. So all reflected rays meeting at one point. Really meet means here the concave mirror we get a real image. Okay, real image. So they are really meet one point. That point is called the principal focus of concave mirror. Okay, Yes. Next here, principal focus of convex mirror. Principal focus of convex mirror. Take convex mirror here. This is my convex mirror. So hollow surface should be silver coated and bulged surface should be reflecting surface. Okay, this is the bulged surface. Outside is the bulged surface. That is reflecting surface. That type of mirror is called as a convex mirror. Convex mirror. Okay, Vex means here bulged. Okay, vex. So remember here, vex means bulged surface, outside surface. Okay, if you observe this spoon here, outside surface is called the bulged surface. Okay, right. So now pole. This is my pole of the convex mirror. Where is center of curvature? This side or this side? Right side or left side? That must be right side because if you close the, if you complete the sphere or circle, we get center of curvature this side, not this side here. This is my center of, not my. This is the center of curvature of a convex mirror. So line joining of the pole and center of curvature is called the principal axis. Line joining of pole and center of curvature is called as a principal axis of this convex mirror. Yeah. Now in this case also, so we take a beam of rays which are parallel to principal axis. Okay, so I can take here, this is the two rays I can take here which are parallel to principal axis. So these rays towards a convex mirror, these rays which are parallel to principal axis and which are incident on the convex mirror. You know that again. So at this point of incidence, draw the normal. You know, normal. How to draw the normal here? Just join this point of incidence and the center of the curvature. That point is called as a, that line is called as a normal. So this is my normal for this point. This is a normal. This is my normal. Okay. Next, this is what is the angle of incidence here. So angle between the incident ray and normal, that is called as the angle of I. Where is the reflected angle which is above the normal? So exactly this is my reflected ray. This is a reflected ray. For this incident ray, that angle is here angle of R. Angle made by the this reflected ray with normal is called the reflected ray. Okay, next coming to the second incident ray. So now first we identify the point of incident. This is the point of incident for the second incident ray. Now draw the normal. Normal. How to draw the normal here? Just join the point of incidence for this incident ray and center of curvature. This is the normal of this incident ray. So this is called as a angle of I. Angle of I. Where is the angle of R which is down? Because here that line normal is between the reflected ray and incident ray. This is a reflected ray. This is a reflected ray. Now tell me, if you see here from this side here, and these rays are not meeting. So they are these two rays are these two reflected rays not meeting or not reaching the our eye, but they are meet. They are these two rays appears to meet, appears to diverge. They are appears to diverge from it here. So they are meeting. If you back trace it here, these two rays here. So if you back trace these two rays, they are meeting one point. That point is called as a principal focus of convex mirror. So if you observe the principal focus of the concave mirror and focus of the convex mirror, they're different here. Okay, actually, what is the focus here? After reflection, they meet. For example, after reflection, the reflected rays really meet. That point is called as a principal focus of concave mirror. In this case here, these reflected rays here appears to meet and appears to meet or appears to diverge from it here. So from the focus, they are coming here, they diverge here. They are coming from focus, coming from focus, they diverge here. Okay, there appears to meet at a focus. That point is called the principal focus of convex mirror. Okay, in this case here, in this convex mirror, in the convex mirror here, their reflected rays are really meet here. In this case, they appears to meet. That is the only difference between the principal focus of concave mirror, principal focus of convex mirror. Okay, please try to focus these diagrams here. Very important here. Okay. So what is the definition of the principal focus of convex mirror? A beam of parallel rays which are parallel to principal axis. After reflection, they appears to diverge from it. From it means they are from the focus, they appears to diverge from it. That is called as a principal focus of convex mirror. Principal focus of convex mirror. I hope you understood the difference between the principal focus of concave mirror, principal focus of convex mirror. It's very, very important. Ray diagrams also very, very important. We need to draw these all diagrams. Very, very important. Okay, right. So exactly if you observe here, this principal focus always between the pole and the center of curvature. Exactly at a midpoint, exactly at midpoint of center of curvature and pole. In this case also, the principal focus is in between the pole and center of curvature. So these focus divide these center of curvature, center radius of curvature into two equal parts. Okay, so if you divide like if you write like that here, you know what is a CP? CP is equal to R. CP is equal to R. What about I want to take define the length between the distance between the pole and focus. That is called as a focal length. Next year, next terminology, seventh one, focal length. Focal length, focal length that is represented by small f. Capital F is the point. Capital F is the point, the principal focus. Small f is the distance between the focus, sorry, the pole and the focus. Distance between the distance between pole and focus. Pole and focus, that is the focal length f here. So if you take this diagram here, CP is equal to R and FP is equal to what is FP here? Focal length. So this is a small f here. This is a small f. Here also small. This is small f. This is small f here. Okay. So FP is equal to F. CP is equal to R. I can write here CP is equal to FP plus FC. FP plus FC. So CP is R. FP means small f. Both are equal means this is also F or not? Yes. So F plus F, that is 2F. So R is equal to 2F, then F is equal to R by 2. R by, that is they may ask here, he may ask here what is the relation between the focal length and radius of curvature. That is here R is equal to 2 times of focal length. So in the examination here, find out the radius of curvature if focal length is 20 centimeter. Okay, na? In the polyset, mainly in the polyset examination, he may ask like that. If the focal length of the spherical mirror is 20 centimeter, what is the radius of the curvature? Just to double it here, 2 into 20, 40 centimeter. Otherwise, here he may give focal length is equal to R by 2, half of the radius here. If the radius of the curvature is 20 centimeter, what is the focal length of the mirror? That is a 20 by 2, that is a 10 centimeter. So simply R is equal to 20 centimeter by 2, 10 centimeter is the focal length of the that mirror. Okay, this is a focal length, principal focus, principal axis, and center of curvature, radius of curvature, and the pole. Okay, and also normal. One more thing in terminology, that is aperture. Please take the screenshot, all of you. Right. Right. Next here, aperture. Aperture means here it is the diameter of the spherical mirror or diameter of the enclosed circular portion of the spherical mirror. For example, this is my this is called as the aperture. Okay. For example, this is the diameter of the, for example, this is if you complete this curvature, this is the aperture. This is the aperture. This is called as the aperture. So this is the aperture. This is the curved surface. So diameter of the I'll write definition here, diameter of enclosed portion of spherical mirror. Spherical mirror is called as the Aperture. Aperture. This is the terminology we need to remember. Based on this all terminology, you may ask define the following terms. The board examination will define the following terms. First, pole, center of curvature, radius of curvature, and they may if it is 4 marks question, he may ask four terminology: pole, center of curvature, radius of curvature, and aperture. Otherwise, here pole, center of curvature, radius of curvature, principal focus. He may ask separate here. Draw the ray diagrams uh, to explain the principal focus of convex mirror as well as the concave mirror. Okay, so especially in the area of principal focus of concave mirror, principal focus of convex mirror, both are very important. Okay, right. And also relation between the focal length and the radius of curvature, that is f is equal to r by 2, or r is equal to 2 times of focal length. Okay, right. Next here, so I want to explain here. So I would like to explain sign conventions. Sign conventions, very important here.
Sir, aperture, you told that the diameter of unclosed portion is curved mirror or spherical mirror.
It is an enclosed surface, enclosed portion of spherical mirror.
In
Okay.
book they gave curved mirror, no sir.
Curved mirror means spherical mirror. What is spherical mirror? Curved mirror. Spherical mirror nothing but a curved surface. Spherical mirror is a part of the sphere. Is a part of sphere or not? You may call spherical mirror or curved surface. Both are same or not?
Okay, sir.
Not. Okay, now understood?
Okay, sir.
Right. Next year, before that year, you should know some terminology and letters which is represented by object, and image, object distance and image distance. For example, if you take here, this is my, for example, if we take a plane mirror, if it is for example plane mirror, this is my object here, okay, and distance between the object and that mirror is called as the object distance, that is represented by u. So in the plane mirror, the distance between the object and the mirror and the distance between the mirror and the image both are same. That's why image is here I. So this distance between the mirror and the image is called as the image distance. Okay. Similarly here, I want to take one more here. Sign conventions are very important here. Sign conventions. So one of the important question here. Sign convention. Sign conventions. First one, for example, if you take a concave mirror, this is a concave mirror. This is a principal axis. Every time we need to draw principal axis. That means it is line joining of pole and center of curvature. Okay? Yeah. How to give the sign convention for each and every distances. Here we are measuring the object distance, image distance, and radius of curvature and focal length also. Okay? Tell me. First one here, all distances which are measured from only pole. For example, in mathematics here, coordinate system. Coordinate system means here x and y. This is the center point. This is x-axis and y-axis. They are meeting at one point. That point is called as the origin point. So that is the 0, 0, 0. So always we can represent that graph should be from 0 only. Same thing also, the pole is taken as a origin point. All distances which are measured from only pole. So all distances which are from only pole must be measured from the pole. Okay, yeah. For example, if you take mathematics here, if you go in the past x direction from the center, from the origin, that is taken as a positive. If you go negative x direction, that is taken as a negative. Same thing also. For example, all rays which are coming from the object, which is always going towards mirror. For example, these are the incident rays. If you measure the distance in the direction of incident ray, that is taken as a positive. So if it is in the direction of in the direction of incident ray. Incident ray, that is a positive x. We are also measuring from incident direction, that is taken as a positive. Positive. Next year, if it is opposite to the incident ray, that is taken as a negative. Opposite. So opposite in the direction of in the direction of incident ray. Incident ray, that is taken as a negative. For example, I can take here, this is my mirror, concave mirror. Okay, these are the incident ray and one more incident ray. After reflection, they meet one point here. This is the image. For example, this is the image here. This is my object here. For example, here object is there. O object. So, for example, pole here. If you measure distance from pole to object means here we are measuring negative x direction. That's why. So, this is the direction of the incident ray. This is the measured direction. So, both are different here. Therefore, we can take it as a negative. For example, image forming at this point here. If it is forming an image at this point here, so we are measuring image distance from pole in this direction. Direction of the measured value in the direction of incident ray, that is taken as a positive. Okay. Next one here. Next sign convention. If you measure above the principal axis, if you measure height of the object, if it is above the principal axis, that is taken as a positive. Above principal axis, that is taken as a positive. For example, this is my height of the object. For example, 2 centimeters. So height of the object is here, we take plus 2 centimeter. Because of this object, we are getting the image here, which is below the principal axis. That is taken as a, for example, height of the image is, for example, 3 centimeter. So definitely we should take a hi is equal to minus 3 centimeter because it is below the principal axis. If it is above the principal axis, which is taken as a positive. If it is below the principal axis, which is taken as a negative over below. So below principal axis, below principal axis, that is a negative. Okay, so first point, second point, third point, and fourth point. So we need to remember all these points for sign conventions. So if you know the sign conventions here, we are easy to find out the image distance, object distance, and focal length also. For example, if you take a convex mirror or concave mirror, this is concave mirror, and this is center of pole of the mirror. This is center of curvature. Can you tell me? This is a focus. Focus means exactly midpoint of center of curvature and the pole here, and distance between the focus and pole is the focal length here. Okay, na? Can you tell me what? Yeah. What is the focal length here? Which is negative or positive? Means here we are measuring the distance from pole to focus. But the incident ray which is going in this direction, but we are measuring opposite to the incident direction, focal length is always negative. It's very important here. For concave mirror, the focal length always negative. Very important here. 1 minute. Just a minute. Now.
Sir, your video is stuck.
Okay, just a minute. I solve your problem. Yeah, right. So this is the sign conventions here. For a concave mirror, the focal length is always negative. Okay, na? And what is the radius of curvature also? radius of curvature of the concave mirror also negative. So radius of curvature also always negative for the concave mirror. It's very very important here. What about the convex mirror? So central curvature this side here. See, this is a pole. This is a focus point. Focus here. Distance between the focus and pole is here. Focal length here. So in this case here, we are measuring distance from pole to focus. The incident ray also going in this direction, both the same direction. The focal length of convex mirror the focal length always positive, always positive. You should remember it's very very important here. And in both cases, in any case here, the image object distance always negative because they are measuring your distance from pole to object this side only, left side only. That's why you always negative, you always negative. In this case, so you also always negative. So remember here, 2 points very very important here. Object distance always negative minus u. For any case here. And what about the focal length? The focal length of the concave mirror negative. And radius of curvature of concave mirror negative. This is about the concave mirror information. Very very important here. What about convex mirror? So for object distance, in this case also negative because we are measuring from the left side, pole to left side. That's why negative x-axis. That's why minus u. This what about the focal length? The focal length of the convex mirror is always positive, and the radius of the curvature is also positive. This is about the convex mirror. Okay. Yes, this is sign conventions. Very very important here. Next year, go for the next image formation. Image formation. Before that, here we should know rules. Rules for formation of image for concave mirror and a convex mirror. It's very very important. Yeah, rules for formation of image by spherical mirrors. Spherical mirror. Okay. Yeah. So in this first rule here, rule number 1. So if you know all rules here, therefore you can understand the image formation by concave mirror as well as the convex mirror. Okay. First rule number 1 here. So I take a concave mirror. This side I can take concave mirror, and the right side I can take a convex mirror. This is my concave mirror. And first indicate the principal axis and indicate first pole and center of curvature, and line joining the center of curvature and the pole is called the principal axis. Same here also I can take a convex mirror. This is my convex mirror. This is center point. It's called pole here. This is the center of curvature C. Line joining of center of curvature and the pole is called as a principal axis. Okay, right. Now the first rule here, rule number 1 is here. A beam of rays which are parallel to principal axis. Okay, just I draw the rays here. This is the one ray and second ray. You can take so many rays here. This is the first ray and second ray. This is also third ray and fourth ray, which are parallel to principal axis. Parallel to principal axis. After reflection, they meet at one point. That is rule number 1. So once again, a beam of rays which are parallel principal axis, they pass through the principal focus. So after reflection, they pass through the principal focus. This point is called as a principal focus. Okay, this is the rule number 1. Once again, a beam of rays which are parallel to principal axis. After reflection, they pass through the principal focus. That is called as a rule number 1. If it is a concave mirror. What about the convex mirror? Again, take the parallel beam. A beam of parallel rays which are parallel to principal axis. After reflection, they are diverged. They are appears to diverge from it. So here, this is a reflected ray. This is my reflected ray. This is a reflected ray, and this is a reflected. They are, if you back trace it here, they pass to the focus. Once again, this is a focus F. A beam of rays which are parallel to principal axis. After reflection, they appears to meet a focus. They appears to meet a focus. That is called as the rule number 1 for the convex mirror. What is the rule number 1 for the concave mirror? A beam of rays which are parallel to the principal axis. After reflection, they passes through the they are passing through the principal focus. Principal focus. Here, the beam of rays which are parallel to principal axis after reflection, they are appears to meet. They are appears to meet a focus. They appears to meet a focus. That is called as a rule number 1. Next, rule number 2. Rule number 2. What is rule number 2? Reverse here. In this case here, the rays which are parallel. After reflection, they are passing through the focus. Now here, the rays which are passing through the focus, after reflection, they become parallel. Reverse here. So this is my principle. This is a concave mirror. And this is a pole. This is my central curvature, and this is the line joining of pole and central curvature. Now this is the focus. This is the focus, exactly midpoint of the central curvature and the pole. Now the rays which are passing through the rays which are passing through the focus, after reflection they become parallel. After reflection they become parallel. They become parallel. They become parallel. Reverse here. Here first is they are parallel to principal axis. After reflection they are passing through the focus. Now the rays which are passing through principal focus, they become parallel. Only change the direction here. This is the incident ray. It means here the beam of rays which are parallel to principal axis, after reflection they are passing through the focus. Now the rays which are passing through the focus, after reflection they become parallel. They become parallel. That is the rule number 2 for the concave mirror. Okay, what about this convex mirror? This is my convex mirror. This is my principal axis. This is the pole. This is center of curvature. This is my principal focus. Okay, next here. So same thing. So where is the rays which are appears to meet focus. So this is the ray which is appears to meet focus. This is also one more ray here, appears to meet focus. After reflection they become parallel. After reflection they become parallel. This is the rule number 2 for the convex mirror. Convex mirror. Okay. So rule number 1, rule number 2. Next, rule number 3. Please take screenshot. Right. Right. Rule number 3. Rule number 3 here. So I take a concave mirror. This is the pole. This center of curvature. This is the line joining of center of curvature and pole is called as the principal axis. Yeah. The ray which is passing through center of curvature, after reflection, it is reflected back and it's follow the same path, which is reflected along the same path. For example, one ray is there which is passing through the center of curvature. After reflection, it follows the same path. It is reflected back and along the same path. For example, one more ray which is passing through the center of curvature. After reflection, again it is reflected back along the same path. That is called as rule number 3. For example, one more ray. The ray which is passing through central curvature and after reflection again follow the which is reflected back and follow the same path. This is the rule number 3. Next here for convex mirror. For convex mirror, this is a pole. This is the center. This is my line joining of pole and center. Pole and center. Okay. Right. Next here. So the ray which is appears to passing, that is the center of curvature. After reflection, they reflected back along the same path. This is a case for the convex mirror. Again, if we take one ray like that here, again after reflection, which is reflected back along the same path. This is a rule number 3 for the convex mirror. Okay, last Rule number 4. Rule number 4. We write all these points in the notebook here. Okay, na? So it's not possible to write every point on the board here because here our course is only 45 days. I want to complete every chapter. That's why. So it will take more. If I write everything on the board here, so it will take more. That's why. So we need to. So we need to write every point on the notebook here. So this video also available in my this app here. So if you have any free time is there, we can listen so many number of times. You can watch number of times here so that we can get clarity. Okay, na? Some people they are not unable to follow it. Other no problem. Again, we have to listen to my class because all recording classes are available in my app here. Please watch it. Okay, because we are free in the daytime also. We can watch it. Okay, and one more thing is here, and I want to tell you, May 2nd to 15th year, I have workshop is there, and in that day, whenever I have free time is there, I record my class here, and I will send same time here, recording class, not live class here, only 15 days, only so May 2nd to 15th, because I'm busy with some workshop here. I have workshop is there, training program is there. That's why definitely, and as per my schedule, I'll send every day one video, which is recording class. After 15th, I will take live classes here. Okay, but whenever I'm free, I'll take after completion of workshop and evening time, I'll record the class and I will send morning or otherwise evening time also. Okay, right. So rule number 4 here. Rule number 4. This is my concave. This concave mirror. The ray which is a fall on the pole and the ray which is reflected symmetrically back that is called as rule number 4. If it is a convex mirror, convex is the pole here, the ray which is a fall on pole which is symmetrically reflected back, this is rule number 4. Okay, these 4 rules are very important for the formation of image, okay. Yes, next year and next class here, so I'm going to discuss an image formation by concave mirror as well as a convex mirror. I think next class I will complete the total reflection of light. That means here I think I'll take only 3 classes to complete reflection of light. Day after tomorrow I start the refraction of light. It will take only two classes only to complete refraction of light. Okay, if it is possible, I'll tell you 1 to 2 problems to complete the total optics. Okay.